let's introduce our next vocab word. Our next vocab word is row echelon form. Basically, row echelon form is upper triangular form, except one difference, we have ones on the diagonal. So you'll notice right here, there's our upper triangular form. The only difference is on the diagonal, I make sure to have ones. Whereas that didn't necessarily happen in upper triangular form. Here was our upper triangular form, and the diagonal could be any number we wanted. So it's basically the same thing as upper triangular form. The only difference is we need to get ones on the diagonal. And I'll show you how to do that in our next example. So here's some more examples of row echelon form. This one is in row echelon form, upper triangular form, ones are diagonal. We do have a row of zeros. As soon as you see that row of zeros, that should make you think consistent dependent. This is an example where you would need to do the T thing that we did last class. Anytime you get a row of zeros, that's a consistent dependent system. Now, this is another example. Technically, this is in upper triangular form, and we've got ones on the diagonal, so that is row echelon form. Now, here are some examples that are not in row echelon form. For example, this is not row echelon form. It is upper triangular form, but because we don't have ones on the diagonal, this is not row echelon form. This one is not row echelon form because we don't have ones on the diagonal. However, we could flip-flop these two rows, and then we would have this one would be here, and this one would be here. So if we flip-flop those two rows, then it would be in row echelon form. This one is not in row echelon form, even though it looks an awful lot like this one, because the row of zeros is technically in the wrong place. If you have a row of zeros, they need to go on the bottom row. That's the rule. So row of zeros, if we have one, needs to go on the bottom, and then we have ones on the diagonal. That would be row echelon form. Now, to get it in row echelon form, we're going to do the same exact steps we did in the last video, meaning write it as an augmented matrix and then get the zeros in the right place using elimination. So let's start by writing example 2 as an augmented matrix. So there's my equal sign. To the right of my equal sign is my numbers that it's equal to. To the left of the equal sign are my coefficients. So 2, 3, 1, negative 1. Now, here's the augmented matrix. I want a 0 here, and then I want ones on the diagonal. That's my row echelon form. So let's start with the zeros. Always get the zeros first. Get zeros first. So I need to get a 0 here. So I am going to work with row 1 and row 2, and I'm going to do elimination like we did in the last video on the first column, and then I'm going to use that answer to replace the second row. So take row 1 and row 2. We're going to do elimination on the first column, and whatever answer we get from that elimination, we're going to replace row 2 with it. I want you to practice this on your own, so pause the video, do that elimination, replace the answer, and then come back to check your matrix to see how you did. Let's see what you got. So I multiplied the second row by -2, so I get the first column to do elimination, and then I replaced the second row with that answer. So I now have my 0 in the right place. So right now, this is in upper triangular form. So I have 2 more steps to get it into row echelon form. So the first thing I'm going to do is I need to get the ones on the diagonal. So let's start with our top one. Now that, actually, let's make a note. Now that all zeros are in place, now take care of ones. So we have all the zeros in the right places that we need. Now we can start to take care of the ones. So let's start with our top row. I need this 2 to turn into a 1. So basically what I'm going to do is take row 1. I'm going to divide all of row 1 by 2. So I'm going to take all of the numbers that are in row 1 and divide them all by 2. So 2 divided by 2 gives me 1. 3 divided by 2 gives me 3 halves, and 6 divided by 2 gives me 3. I didn't touch row 2 yet. So now you'll notice I have my 0 in the right place, and I have my first 1 in the right place. Now I need to get this to be a 1. So I'm going to take row 2 and divide everything in that row by 5. So row 1 stays the same, and I'm going to divide everything in this row by 5. So 5 divided by 5 is 1, 5 divided by 5 is 1. And we now have row echelon form. We have our upper triangular form with 1s on the diagonal. This is row echelon form. Now the reason we get it into row echelon form is it is super easy and fast to solve once it's in row echelon form. Let me show you how. There's my row echelon form matrix. I'm going to add the letters back in so you can see what's going on here. So this becomes 1x plus 3 halves y equals 3. And that one's 0x, so 1y equals 1. And look at that. I can get rid of my 1 coefficients, don't need those. I already have y totally solved for. Y is done. So now all I need to do is plug that y back into the first equation to solve for x. So this is x plus 3 halves equals 3 minus 3 halves. I get x equals 3 halves or 1.5. And you're done. You have your point. Point is 3 halves comma 1. It is a single solution, so this is a consistent independent system. And that's how we work with row echelon form. We get the zeros in place first, then we worked on the ones in the diagonal, and then it's pretty quick and easy to solve once we put the letters back in. So here's so let's end the video there. That was a 2 by 2 for row echelon form. In the next video, let's try a 3 by 3 to get it into row echelon form, which is a little bit more work, but we'll do it together and you'll be fine. So I'll see you in the next video.